Okay, so this is chapter 4, problem number 30. And so the question asks, an object with mass m1 equals 5 kilograms rests on a frictionless horizontal table and is connected to a cable that passes over a pulley and is then fastened to a hanging object with mass m2 equals 10 kilograms, as shown in figure P4.3, which is that figure. Find the acceleration of each object and the tension in the cable. So, we would start out with drawing the figure. So, and then you can label this one M2 and this one M1. And then you can label the forces after that. So on M1, there would be a normal force going up, the tension from the cable, and the weight. And for M2, it would be the tension and the weight. And after that, you can label your X and Y's. So, since M2 is 10 kilograms and M1 is 5, then the M2 would obviously be going downwards, and then M1 would be going to the right. So for M1, you can do the positive X direction would be to the right, then positive Y would be up. And for M2, the positive Y direction will be down, since it's moving downwards. And then after that, you can start with M1 for the formula. And then, well, first you should write the force equals MA. Okay, so for M1, the sum of the force of X would equal tension, which equals mass times 1 acceleration. And then, well, you can't really do much there, so you can move on to the y-axis one. So sum of the force of y equals normal force minus mass 1g equals mass 1 times acceleration. And then you can't really do much there either, so you move on to M2. So for M2, it would be sum of the force of y equals m2g minus t equals m2a. And then so it would be m2g minus t because tension is in the upwards direction and that's in the negative y, so it would be negative. And then m2g, that's the weight, so that's the force going downwards, so it's the positive y direction. And then from there, you can use this equation here and add it to this equation because the tension and the acceleration of the M1 and M2, they're the same because they're on the same piece of string or cord, whatever. And so they're going the same acceleration and they would have the same tension. So it would be T equals M1A, and then the tensions would cancel, so it would leave M2 gravity equals acceleration times mass 1 plus mass 2. And then from there you can simplify the equation to solve for acceleration. So acceleration equals m2g divided by m1 plus m2. And then from there you can plug in your values. So acceleration equals 10 kilograms times 9.8 meters per second squared times gravity divided by 5 kilograms plus 10 kilograms. And then, so if we calculate that out, that would be 6.53 meters per second squared. And then once you found your acceleration, you can plug it back into either that formula or this formula. And then I'm going to use this one. So tension equals mass 1 times acceleration. So 5 kilograms times 6.53 meters per second squared. And then if you calculate that, that will be 32.7 newtons. So that's the tension. And then, yeah.